how can I understand effectively the function notation? Function notation is one of the topics in algebra, in high school mathematics, that the students struggle to understand lifetime. This video is to share with you how I can effectively teach this topic in order to have better results, better outcomes with my students. What is the problem? The problem is the misconception, and is the brief or quick transition from y equals into f of x equal. And the students do not understand that transition so fast, so quick, because we have misconceptions. One of the misconceptions, for example, is they do not relate that when we work with f of x equal y, we are working with the concept of function. And if we don't know the concept of function, if we don't know what is the relationship between input and output, that in that relationship we have a rule, we have a process that turns some input into some output, then we cannot understand f of x equal y. This is number one. The understanding of the function definition, that is a relationship, is a special relationship between two sets in which we have a process in between input and output. We have a process in between, and that process is what we call function. Then the students will not understand function notation so easy. So we have, for example, common misconception that I have found in the past. Students think that f of x is like a multiplying f times x. They have seen letters next to each other means multiplication for years. So f of x looks like f times x instead of the value of the function f at input x. And again, you can see the relationship here between input and output based on the function definition. Another misconception. The student think sometimes that y and f of x are two different things. We switch from y equals 2x plus 3, the linear equation y equal mx plus b, to f of x equal 2x plus 3 with almost no transition. For a student, it feels like a new topic, not just a new label. The key idea why is just another way to write f of x is not effective. And personally, I have used that phrase millions of times. Why is this just another way to write f of x? And we have a function notation, and we can talk about history of mathematics and how that function, that notation was introduced in the history of science or mathematics. This is not enough. Why is just another way to write f of x is not effective. So these are common misconceptions. For example, input and output language is not solid. Many students don't have a firm sense of input, process, output, the definition of function. So f of x is just a symbol, not take what is inside the parentheses, run it through the rule, and that's the output. Then evaluating something like f of 3a that they will see more complex structures and more complex math courses, or f of x plus 1 fixed like a random substitution instead of whatever is inside is the input. So my recommendation to you that is watching this video and want to learn math, solid math, math with a rigor is that to understand things in mathematics, to understand the structures in mathematics, we have to understand what is behind the structures, what is the justification behind the structures, and what the structures represent. Is a window, is a door. Cannot be a window and a door. So if we talk about f of x as a function, we have to put emphasis on functions. This is the way I learn math, and this is the way that I teach math. Welcome to Math Topics. Now I invite you to discuss questions like this. Connecting different representation. We have a table. The table shows a function. Use a function notation to write three true statements like f of input equals output. This is essential. I always try to take the students or to bring the students to this expression here. It's too much better than f of x equal y. It's more the students get more understanding if they see it first this way. So this is the domain, and this is the range. This is the input, this is the output. But there is something in between here that we don't see, it's invisible, that is called the function rule or the process. I like the word process. And now the students can do this here. F of -2 equals 3. Input, output. F of 0 equals 7. Input, output. F of 1 equals 9. And this is f of input equals output. This is the way I teach math, and this is the way that I learn math. And this is an approach that is more effective than quick transitions. Quick transitions, that they don't work in lifetime's learning. They don't work in lifetime learning. And you can make a transition here to points, no? You know that all of these are points, x and y, no? So -2, 3, and you can make the transition to x, f of x, or input, output. So you have to play with that more time. This is about time. This is not just move on. So look at the question 2. The point 5, -2 is on the graph of certain function g. Write this using function notation. So I know that now we are not working with f, we are working with g. Now is g input equals output. The structure stayed. And this is g of, let me put it over here, g of 5 equals -2. And that's the point. And you bring the students back and forth between different notations and different structures, but they represent the same. In words, what does your answer in A mean? That for x, for the input equal 5, certain process occur, and then we have an output equals -2. Why we cannot have sentences in mathematics? Why we cannot tell the students to write sentences in mathematics? Writing sentences in mathematics makes the students understand better because they're using another sense, another perception, another approach, which is writing. Writing, listening, viewing. So all of those activities, intellectual brain activities, keep the brains functioning. So in words, what does your answer mean? That for input 5, certain processes occur that I don't know in order to produce the outcome -2. We have here one more example, more mathematics example. So we are making a transition to a linear function. Specifically, we have the process here. And it's important to call 2x plus 5 in number 3 a process. This is a process. The students need to know that there is a link between the input and the output, and that link is a process. It's a mathematical process. And what is that mathematical process? Twice a number plus 5. Twice a number plus 5. This is the process. And you can ask the students to name the process, to describe the process. What is the process? I get a number, I multiply by 2, and I add 5. And my answer is the output. My answer is my f of x. My answer is my y. My answer is my output. My answer is my range. My answer is my dependent variable. And this is the conversation. But this is a building that you have to start creating, but not in a quick transition, not in a quick process, because not everyone can understand abstractions so fast, so quick. So now the students know that this is 2 times 0 plus 5, and this is 2 times 3 plus 5, and this is 2 times -4 plus 5, because they understand the process. They understand what is going on here. In order that process, that machine, some teachers, they call it machine, that process works, we need material. No? We need a material. What is the material here? The numbers, the inputs. What is the process right here? The process right here is square a number and subtract it triple. And I'm phrasing and making the students writing. It's going to make the students understanding. Pick a number. 5, square the number, 25, triple the number, 15, subtract that. That is the process. This is the process that is going on between the input and the final destination. And we have to represent that visually with letters, with sentences, with phrases, with conversation, in order for the students to know that this is 1 squared minus 3 times 1, and -2 to the second power minus 3 times -2, and 5 to the second power minus 3 times 5. The students can see the triple of the number, the triple of the input, the triple of the x, the triple of the domain, and they can see that also you are squaring the domain, you are squaring the input. So before translation to mathematics structures, we had to talk. We had to make the students write and speak. If you want to create a solid understanding of function notation. And this is the algebraic approach. And then we can move it to the function approach, the graphing approach. How to see that in a graph. How to see actually that in a line, 2x plus 5. How to see that in a parabola, x squared minus 3x, or in any other function. And then the meaning. This is the final. A function c of t gives the cost of renting a bike in $ after t hours. A function c of t gives the cost of renting. It's cost, it's money, it's how much you're going to pay. What does c of 2 represent in words? And then B, if C of 2 is 18, explain what this means in a sentence. What that Z of 0 represents in this situation. Who is the input here, the time? So 2 is time, 0 is time. Before talking about the function in particular. The function in particular, we don't need the structure yet. We don't need the expression yet. We need to talk. C of 2 is how much is going to be, how much I'm going to be paying after 2 hours renting a bike. That's C of 2. If 2 is time. And C of T is the cost of renting. So how much I'm going to be paying if I rent a bike for 2 hours. But look at B. B is a totally different scenario. B here is clearly the full idea. Times 2, money $18. So 2 hours of renting, you paid $18. We're not talking here about expressions. We're talking about here meaning. C of T is money. So C of 2 equals 18 is money. Money. 18 is money. So you will be paying $18 after 2 hours of renting a bike. And 0 means no times. 0 times. You're not renting anything. You are going to pay something that you're not renting? Students, teachers, viewers, we have to be creative in order to be effective. I hope you like this video. You give us a like, you share this. And if you are a teacher, try to create scenarios like this before going over functions structures like mx plus b, quadratic functions, or trigonometrical functions. Even if the students reach a pre-calculus class or a calculus class, you have to reinforce the idea of functions again, the idea of input and output, the idea of the processes and the common misconceptions. Because those common misconceptions can affect the learning. Thank you for watching. See you in the next video.